The title of this talk is Walking on Water, Wastewater. Most should be familiar with this adage. People who live in glass houses should throw stones. But this is probably new to most. Beware of launching a boomerang. And hopefully, by the end of this lecture, the meaning of this will become clear. Florence Nightingale is credited as being the first person to make the link between the hospital built environment and patient ill health. What she said so eloquently more than 160 years ago is still true today, unfortunately. Within days of opening, patients die. Within days of opening of a new hospital, patients die from avoidable infections from the built environment. It might be nice to think reassuring that when you've got a brand new hospital, those are lucky to get it, that this is like a fortress. Or if you don't believe that, you may think that once you put a patient in an isolation room and the door is shut, they're not at risk of acquiring infections. But this is not the case. And the problem doesn't just begin elsewhere in the hospital. In fact, it begins several miles away, or even further, depending on local circumstances where the hospital is built. Now, if we go to the water treatment plant, which may be the other side of a city, water is piped, normally through underground pipes, into buildings, and the water contains its own normal microbial flora. And these are termed opportunistic premise plumbing pathogens. And these organisms are capable of causing disease, especially if they multiply up to high numbers. But in immunocompromised patients, these organisms will cause infections. Equally, patients bring organisms, patients, staff and visitors bring organisms into a building. And the large bowel of the humans contains more bacteria than there are people on the planet or cells in your body. And this is where some of the most highly antibiotic resistant organisms reside, in the human gut. So naturally, as people enter a hospital, they will bring their own microbial flora, which may contain highly resistant organisms, and these may then enter the systems in the hospital. So if we go back to outside the isolation room, what we're talking about, if we look at the flooring and make this transparent and look underneath, we can see the pipework. This will include the hot and cold water systems, but also the wastewater systems. And these will bring microbes in to the patient's room, which may produce infection. And so this talk primarily concerns about the risks from wastewater systems. We've just overlay on that the ward. So this is the water pipes, and underneath you can see the wastewater pipes. So the requirement to segregate water and have sanitation goes back in time. The Romans were not the first, but they knew the importance to segregate clean water from contaminated wastewater, so they developed sanitation, and this is some of the drainage services from the Romans. But unfortunately, the concept got lost in the midst of time. And with the Industrial Revolution, there was a large influx of the rural population into cities, which lacked both sanitation and safe water. Cesspits became common at the bottom of each house. The disease became rife, and this was associated with the smell. And the Victorians thought that the disease was spread through the air, and unfortunately they thought, because of this, they ordered the cesspits to empty into the Thames. And up to then, the Thames had been a relatively safe source of drinking water, and of course when the cesspits entered it, it became contaminated. And as somebody wrote at the time, the present system of London water supply, a portion of the inhabitants are made to consume a portion of their own excrement, and moreover to pay for the privilege. And the big stink which arose because of the emptying of the cesspits into the Thames drove Parliament to introduce change. And interestingly, this was in the same year that Florence Nightingale produced her book of notes on hospitals. So wastewater systems and Florence Nightingale are linked in time. And because of the contaminated wastewater systems, cholera became a major driver for safe water and sanitation. And this is the famous artist's impression of John Snow breaking the pump in Soho to end the cholera outbreak. And here we see Sir Joseph Bazalgette overseeing the building of the sewers in London, which still stand today. So we've moved from fecally contaminated wastewater. We now have, in developed countries, we're lucky, we have high quality water. We pump that into buildings, and we learnt about Legionella. And we're now only beginning to recognise the risks from the periphery of the water system, which may be arbitrarily defined as the last 2 metres of pipework, connected devices and associated wastewater system. So this is an interface between the water and wastewater system, and there's a wide range of organisms, and I think we need to start thinking what the size of the problem is originating from the periphery. The first area on the hospital to move to water-free care was not a patient area, but this was a sterile area, a sterile production area in pharmacy. And this resulted because in 1995, total parenteral nutrition was prepared. It was given to paediatric patients, and they died from infection. And this was traced back to splashing from a nearby sink, getting into the TP, and it was made. So the view from the pharmacy, the sterile services in pharmacy, is water is so unsafe, you keep it out of the department. People decontaminate their hands before entering or use alcohol gel. So if you look at most buildings, they are connected to the wastewater system. And if you were an alien and you wanted to sneak into people's houses and it was small enough, you could do it from the wastewater system. But what we're going to concentrate on is the wastewater systems in hospitals. And if we look at these, as we would expect, if we looked in the main sewage stack, what we will find is human feces and other body fluids. And as we've already stated, this is where some of the most highly antibiotic resistant organisms reside, which threaten the end of the antibiotic era. So the question is, if we had, these are 3 patients in geographically distinct areas of the hospital, if one has a highly antibiotic resistant organism, how is it that it may be communicated to others in quite distinct areas? And could the answer be it is actually via the wastewater system? So how do organisms move around wastewater systems? This is a wonderful paper that came out of St George's in 2012. It took 5 years to uncover the outbreak, and what they showed was that the wastewater system acted as a superhighway for the spread of highly antibiotic resistant organisms through a healthcare facility. And these were emerging at blocked sinks, blocked showers, anywhere where drains were blocked or poorly constructed, 90-degree bends. So what happens when you flush a toilet? As you might expect, the water and feces enter the main sewage stack, and you expect them to fall by gravity towards the ground. This is the case, but as this falls, air has to escape, which creates an upward draft, which creates a suspension of water and fecal material, which can travel several stories up. The first clue that came to this was in the first outbreak of SARS. There was an immunocompromised patient, and these patients can shed the virus, still biologically active, in the stool for a prolonged period of time. And they were living in these high-rise flats. And this is looking down, this is on the same floor, there are several flats on the same floor, and you might have expected that if there was transmission in the building, it would be people on the same floor who would be using the same services, the lift. However, this was not the case. It spread vertically, and was thought to be via the wastewater systems. And this is work done in Edinburgh, and what they've done is they've created a sewage stack here, several stories high, and they've got a tracer organism Pseudomonas putida. So they made a suspension of this, equivalent of fecal suspension with water, somebody gone to the toilet, and if you note at the top there's a toilet, and the U-bend is they've reduced the level of water, so there's a communication with air in the sewage stack and and air outside of the toilet. So they did equivalent to flushing the toilet, put the Pseudomonas putida in the stack, and what they could show is that the Pseudomonas putida could be detected several stories higher either by air sampling or contact plates on the toilet, showing that these organisms can move up a vertical stack. And of course, within a building, all services are connected to the sewage stack, be they the kitchen sink, your bathroom sink, shower, or the toilet. Blockages in hospitals are common. Wipes are a common cause of these blockages. In some hospitals, more than 400 blockages a year. And when this happens, you can see how you can get back contamination, and you may see feces actually emerging in showers. But on top of this, we pour still biologically active antibiotics into the wastewater systems. A recent study in Germany looked at the concentration of antibiotics in the waste traps of showers, sinks and toilets, and they found biologically active antibiotic. People do pass urine when they're in the shower, so they flushed the services out, which should have got rid of the antibiotic and took the room out of action. And what they found is that the antibiotics reaccumulated, and what they think was happening is that some of these antibiotics becomes incorporated into the matrix of the biofilm. When you flush the water away, the concentration lowers, so these antibiotics now re-emerge out of the matrix. But it's not a great leap of faith to see how the microbes may now be using our own weapons against us. So by incorporating a broad spectrum antibiotic into the matrix of the biofilm, they now may apply a selective pressure, only allowing resistant organisms to enter the biofilm. You may think this is somebody who's just washed their muddy feet after a walk, but as you can see here, when the toilet is flushed, this is fecal material coming up into the bath because there's a blockage distal to where the pipe, the drain from the bath meets the toilet drain. This is work from America where they inoculated a waste trap with a tracer organism, and this was in a gallery of sinks. And what they found is within 7 days of inoculating the first sink trap, the organism could be found in the other sink traps. If it left longer, it'd probably go to all of them. And the one on the furthest on the left, the bacteria were going up against an upward gradient. So waste traps, their main function is they act as a water seal to prevent the escape of sewer gases, and these come in various forms, including here we see is a bottle trap. Again, the same group in America, they inoculated a waste trap with a bacterial culture, as can be seen. They then put this into a high-risk scenario. So this was a sink where water from the outlet was directly hitting the sieve. They put settle plate, bacteria, agar plates nearby, and they collected splashes, but they couldn't detect any bacteria. But they then repeated the experiment and made one minor change, and this was to add a carbon source. And something quite remarkable happens when you add a carbon source. Bacteria in the form of biofilm now grow up the vertical section of the pipework at an incredible rate of 1 millimetre an hour. If you now put this waste trap into the same scenario and allow water to directly hit the drain, then the agar plates nearby, the transfer of the organisms from splashes can now be detected. So the learning from this is don't pour anything down the sink. It's a zoo down there, so don't feed the animals. Many of the outbreaks from around water and wastewater with highly antibiotic resistant organisms. This is an outbreak from Canada, and this was a multi-drug resistant strain of Pseudomonas. And if we just go into the ITU, there's a door opening, and then you can see the wash basin and a work preparation area. And what they found is when they tested the water, this was free of the highly resistant strain, but it could be found in the drain. So they did a very simple and eloquent experiment. They put fluorescein dye into the drain, as shown. They then shone fluorescent light to make sure there wasn't any background fluorescence, and they then ran the outlet. And what they could find is splashes of fluorescein travelling at least a metre away. They couldn't exclude it going any further. We're now in the room, the ITU room. You can see the sink's been taken out of action, and that's probably less than a metre there. We can now see how splashes of the organism would get into the preparation area and go from there to infect the patient. This is another way of looking at this. This is just introducing fluorescein dye into the flow of water, and this is a result of time-lapse photography. And there's a number of things to note. Some of the splashes are so large they run down the wall. Some of them can get tremendous energy and actually go up quite high, but splashes can travel at a distance of at least 2 meters. So now when you look at a clinical hand wash station or any sink, what you're actually looking at is a rocket launcher. Now this is a piece of equipment which is capable of dispersing either organisms which come out of the outlet in the water, or the water picks up from the wastewater system. And this might seem to be an exaggeration, but it isn't. Hand wash sinks used incorrectly, any sink, actually results in patients' infections and deaths. This is a report from CDC in America. This is looking over 3 years. CDC are called in by hospitals when they need help in investigating an outbreak. And this is looking at water-related outbreaks, excluding Legionella. So they looked at direct or indirect contact with water, that could be introduced by drugs, looked at susceptible populations, and they included wastewater systems. So over that period of time there are 620 investigations, but water or wastewater accounted for more than a fifth of their requests for help. There were 1,380 patients involved, an average of 10.3 patients affected per investigation. Just to put this in comparison to Legionella, in England we get approximately 12 cases of hospital-acquired Legionella a year are detected. 7.5% of investigations were polymicrobial, and a third of infections were with multi-drug resistant organisms. And actually, if you look at the ones caused by Enterobacteriaceae and Pseudomonas, of those organisms, a much higher percentage were due to multi-drug resistant organisms, over 90%. And what they found is quite startling. They found that the infections were being transmitted due to preparation of medication near a sink, nutrition near a sink, patient care supplies stored by sinks and toilets and ITUs, contaminated water from sinks in neonatal units, and contaminated sink drains. Well, you might think, okay, that's America, how about the UK? So this is an HDU in England. People obviously concerned about the quality of the water there. You can see the elbow operated lever can't be operated because it is in the wrong angle and is also being blocked by the dispenser above. But this is a high-risk situation because water will be directly hitting that drain, and that's probably about a metre, so drain contents will easily be reaching this patient. This is a brand new hospital, as yet unopened, and the major concern is everybody's gone through this, the health building notes, the HDMs, and nobody sees this as a risk. Here's a sink right by a clean utility. There's the drug storage fridge there, and nobody sees this as a risk. There's no need to have a sink in this area, but what's worry is nobody is recognising the risk. This is inside the anaesthetic room of an operating theatre, and a child had a long line undergoing chemotherapy put in, and acquired an infection with a non-tuberculous mycobacteria. And a very good infection control team here, and what they were able to demonstrate is that the non-tuberculous mycobacteria came from the tap in the anaesthetic room. In fact, there's a separate sink in this room for a clinical hand wash station, and nobody knows quite why the sink's there, but nobody's recognising the risk. There's PPE, drugs, and also these trays which are used for drug preparation where water from the sink could splash into and quite readily lead to infection, especially as we've seen the case of this poor child who had an infected Hickman line. I'd like to thank here, as you can see, again, a clean utility, storage of equipment, and Peter Hoffman's trousers here demonstrating the splashing. And again, nobody recognising the risk, and really there's no need to have a clinical hand wash station in this environment. So what about the hand wash station design? So what happens if you, instead of having the drain directly below the outlet, you move it to one side? This is one study from America which showed that even when you did that, you still got dispersal of drain contents. What we're not sure is it's water directly hitting the drain, or there's some of the drain contents come back into the flow of water, and this causes their dispersal. In the UK, we prefer to have sinks with a recessed drain, and work from Portland down is showing these are very low risk, providing drainage is not obstructed. And as you can see here, the fluorescein dye which was put into the drain is now coming out. There's a poor drainage in the sink, it's not working as well as it should be, and as you'll soon see, against flow there's regurgitation of drain contents. Again, in fact, up to 9 times the running outlet, you can see fluorescein escape from the rear drain, and you can see again here regurgitation of contents against the direction of water flow. And the reason we have problems with rear drains, and all those items on the back of the sink were found down in the waste trap causing obstruction to flow. And it's because this is the sieve which has been designed for a rear drain, and people, I think rightly, don't want to use this because this is a high risk surface for biofilm formation and likely to lead to issues. So this is the Achilles heel of the rear drain, is that as soon as you get impairment of flow, it starts dispersing wastewater. This was another issue with the rear drain. This is looking from inside the sink, and as you can see here, the rear pipe has been the overzealous use of sealant. So what this has caused is a dam leading to impaired drainage and biofilm, and this was responsible for transmission events to patients. And again here, this is counterintuitive. Putting fluorescein dye is flowing away from the drain. Now, as you can see here, what happens is water meets in front of the drain, the two streams of water hit each other and then pushed forward out away from the drain. And again here you can see, as soon as water enters, you get again fluorescein coming out of the drain, and again this counterintuitive movement away from the drain. This is sped up. I'm afraid it looks a bit like a Benny Hill film. This is just to show you a bottle trap, waste trap. And the first thing to notice is it's compartmentalized. It doesn't require much to cause obstruction. There's paper towels down there, and you can see there's all sorts of items of equipment, plastic wrappers, paper towels, and if you look here you can see a large plastic stopper of a bottle. So impairment of drainage of rear drains, it becomes anything going down there is likely to impede the flow because it doesn't take much to block the waste trap. So what about staff discipline, or I might say indiscipline? This was a study, again coming from the United States. They put a video camera above a sink so they could see what was happening, couldn't recognise individuals. They looked at more than 5,500 behaviours, and the headline figure is that hand washing was only 4% of total behaviours. So 1 in 25 visits to the sink was for the correct purpose, or to put it another way around, 96 out of every 100 visits were for the wrong purpose. And the sink was used for disposal of fluids, it was used as a shelf, you name it, it was done. And what they summed up by saying is that redesigning hospital workflow and sink usage may be necessary, as sink drains as a reservoir for transmission of multi-drug resistant bacteria are increasingly realised. And I think the only part of that sentence one might quibble with is that the multi-drug resistant, and we'll explain this later on. So we recognise that this is a high risk area. We're very quick to recognise the risk that cleaning staff, domestic staff, may clean a drain and then spread organisms to the outlet and other areas. But we're only learning about other groups, how contamination may occur. So here, somebody just taking a cloth to go and wipe a patient's face, by putting it down there, highly likely to pick up drain organisms. But again, we take it for granted. We have a nice clean bowl here, disposable, fill it with water to wash a patient, but the bottom of this bowl is coming in contact with the wastewater system. And just to show this is a nice paper from Ashley Flores, a Dipsy at King's College Hospital, and here they had a number, I think they've had more than one outbreak, and they think this has been linked to these wash bowls spreading CPEs from the sinks, and they've moved to water-free patient care for bathing. Also, when taking jugs of water for a patient, and what happens is the domestic staff, to save time and its weight, will place this in the sink, and again the bottom of these jugs is thought to be acting as a vehicle for the transmission of wastewater organisms to patients. So we also need to consider the chances of our interventions. If we are going to introduce them, what is the chance of them being successful? So unlike, this is actually a representation of the design of a real ITU, and what if somebody's in isolation, one of the side rooms is at the top. If they're in isolation in a medical ward, there's a good chance that the side room will have ensuite facilities, so you can dispose of body fluids within the room. But what we expect staff to do in an ITU is to walk the length of the unit with some of the most highly contaminated secretions, which is a risk in itself, touching a number of surfaces, and also the way this is disposed. And it's not surprising, again, this is a report from Canada. This was a spread of Klebsiella from wastewater systems, and they say whilst it's clearly unacceptable for staff to dispose of these such secretions in hand wash stations, the reality is this is going to happen unless we design it out of the system. Here in France, this is looking at a number of ICUs, and there's 133 single rooms and 13 ICUs, but 52 of the rooms had 2 sinks, and the purpose of the second sink was so you could dispose of fluids in the room. And so 3 conditions were significantly associated with lower ESBL sink contamination rate of the hand wash sink, and firstly a use of a sink restricted to hand washing, and secondly if they were using bleach as opposed to a QAC, and daily use of bleach for disinfection. So we need to think, if we expect people to use clinical hand wash stations properly, how do they dispose of fluids? Simply. So in terms of most effective and least effective, there is a hierarchy of controls, and the most effective is to eliminate the hazard. The second, so that may be removing the sink, isolate to separate the hazard. This could be putting a splash screen in, the engineering solutions to prevent dispersal, maybe offsetting the drain, lowering the pressure. But the most important bit of this is administrative controls, policies, guidelines, education, which we rely on most of the time. This is the least effective intervention. In terms of lowering the risk from wastewater systems, Joachim Kond, who warned the world of the risk of Pseudomonas coming from water systems, but in the UK we chose to ignore his comments in 1967. He also invented the first thermally disinfecting waste trap, because he said a lot of these organisms were coming from the drains, but this people never really took this on. But they're becoming, now people are re-looking at thermally disinfecting waste traps. So people have tried pouring disinfectants into wastewater systems, and they've met varying success. Sometimes it works, sometimes it doesn't work. There's a worry about the contact time with the vertical section, so some people have produced foaming products. And the thing is, even if they do work and you stop using them, the organisms are likely to regrow from the main sewer. In fact, in some hospitals they've replumbed systems, which has brought temporary respite, but even when you replumb the system, eventually the organisms come back from the main sewer to produce transmission events to patients again. So this is now looking at thermally disinfecting waste traps. This is a very nice report. In fact, it's two reports on the same outbreak which came out of Holland. So they thought they were on top of it in 2013, but they weren't, and they had to do subsequent interventions. So just to give some background, this is Leiden University Hospital. It's 30 adult ICU beds, and there's ITU and ITU-B, and they're separated by a corridor, so they have quite a strong relationship with each other. And what they found in the outbreak is they were finding parts of the environment positive, they were finding drains positive, but they weren't sure whether actually what the drains represented was, of course, if you have it in patients and put their secretions, you're going to find it in the drains. But they also found it in faucet aerators, which they found more worrying and probably understanding, because now the water is contaminated. So this is when the outbreak was first noticed, and they did a very good thing. They looked back in time, and when they looked back in time, they've actually got two strains going around. This outbreak had been going on for 21 months, but nobody realised, because every person, lots of people involved, only a small, people were only getting a snapshot, they weren't seeing the overall picture. So this has implications for infection control surveillance. You need to look for these things over a prolonged period of time. And you can see here, this is the outbreak now, continuing. So they tried chlorination of sinks, which didn't really get rid of it. But they then they removed the faucet aerators and introduced a maintenance program. And so in May 2012, they had no new cases for 3 months, thought they were on top of it. Unfortunately, 7 months after the last case had occurred, they had another 4 patients. But again, they got on top of this. But even since then, they'd been getting sporadic cases. So they hadn't found a common source, so they'd tightened up on all the standard infection control precautions, and now they decided to focus on the sink drains. And this was an intervention. It was a 2-armed intervention trial. On ITU-A, they put this thermally disinfecting waste trap, and this operates by when water runs in, it detects water running into the waste trap. This uses agitation, and it goes through several thermal disinfection cycles. But on ITU-B, what they did was they put in new wastewater traps going from the sink to the drains. And so this is quite a busy chart. So at the top, the triangles represent patients. Green is ITU-A, orange is ITU-B. So these are patients acquiring the organism. The hollow squares here are the numbers of bloodstream infections. So here, this is showing the percentage of wastewater traps contaminated. Now, they haven't, so because of nothing here and nothing here doesn't mean they didn't detect anything. It was that they didn't do any sampling, because every time they did sampling, they detected the outbreak strains in the drains. And here you can see that's the introduction to the self-disinfecting waste traps on ITU-A, and you can see it dropped off quite nicely. And then this is the self-disinfecting waste traps on ITU. They then moved them to ITU-B. So one of the questions is, why are some sinks still testing positive? And what they found is these sinks were not being used, and as the thermally disinfecting waste trap is only activated by water running into it, it wouldn't go through a thermal disinfection cycle. And the second thing is, why did installation of disinfecting waste traps on B affect patients on A? And they think it's because the 2 ITUs were in such close proximity, there was movement of contaminated equipment across both sides. And for those of you who want to see the statistical significance, if it's B, you can see it's statistically significant introduction of the waste trap on ICU-A and also on ICU-B. So we'll just briefly look at showers, toilets and kitchens. This is a recently reported outbreak from Germany. This was carbapenemase producing Enterobacteriaceae. They could show the patients having the showers were acquiring the organism. They tested the water was clear. They could detect it in the drains. They put disinfectant down the drains, and although this made the environmental swabs negative, they were still getting ongoing transmission. they put some plates around the shower, and they could show dispersal of CPE when the shower was run. So what they did is they built this plinth, they put this on top, and this did two things. It stopped the patient having direct contact with the drain, and it seems ridiculous that we build drains for people to stand on, which are linked to the toilet. And secondly, it stopped water directly hitting the drain and dispersing organisms. And by placing this in there, occasionally they take it out to disinfect it, they successfully terminated the outbreak. Perversely, some of the most high-risk patients, altered environments, are patients undergoing chemotherapy and will lose their hair, as you can see here. And so you need to think of ways of minimizing this, so it needs enhanced maintenance. This is a new hospital about to open, a very good estates team. You can see the macerator there, and they said they wanted the waste pipe from the macerator to be straight, go into the main waste pipe. They didn't want any 90-degree bends, and what you can see here is the contractors put two 90-degree bends, likely lead to blockages throughout the lifetime of the building because of this poor design of the wastewater system. If we move to kitchens, this is from Germany. This hospital had its own strain of CPE, and it used to rear its head every month or every other month. And then suddenly the number of cases increased substantially. They did a case-controlled study, and they were able to show that acquisition of the organism was linked to eating salads. They tested the salads coming into the hospital. They were free of CPEs, and so they went to look at the kitchens, and what they found was salads were prepared salads were put on a surface near a sink, and what they were able to demonstrate is that water directly hitting the drain in the kitchen sink led to dispersal of the carbapenemase producing organisms, which then landed on the salads, which were a vehicle for transmission to patients. But this wasn't the end of the story, because the kitchen were in a separate building. So the question was, how did the hospital strain get into the kitchens? It could be via a variety of routes. You could argue maybe the underground wastewater system, sewers. But what they found, a more plausible explanation, was this coil, which had gone down the main sewage stack in the hospital. They had a blockage in the kitchen, and this same coil went into the kitchen sink, and they think this is how the organism was introduced, and swabbing this isolated the outbreak strain. So we need to think how people are decontaminating equipment in estates, as this may be moving organisms around a healthcare facility. So what about the future? And this was published a letter in the Journal of Hospital Infection, and this was people saying, well, look, we've screened our drains, we've found these highly resistant organisms, but we haven't found any spread, so why worry? And of course, really this is a very naive view. And it's very good to see Hilary Humphrey's team to go back and explain why this is naive. A, they didn't think their surveillance was good, but there's so much variation between practices, designs of zinc, where they're placed, how people use them, that extrapolating from one situation to everything else does not make sense. This is the reports of antibiotic resistance in the literature, and this shows you the time it takes for them to double, how it's halving. So from 2002 to 2010, it took about 10 years, for the same number of publications, about 4 or 5 years, and then 2016, just a couple of years. But reports of AMR drain-related outbreaks have paralleled these reports in the literature. And in Holland, in response to an intractable outbreak of a highly resistant organism, Drees Topman and team there, they removed water services. And not only did this get rid of the outbreak strain, this was successful, what this did was it produced an overall reduction in all gram-negatives. So going back to say why people only talked about highly resistant organisms, and it was slightly wrong, and what this is demonstrating is highly antibiotic resistant organisms we don't think have any special adaptation to spread from water systems. What they do is they attract our attention. This, if you like cars, is like a Porsche going down the high street in the most brightest colour, blowing its horn, whereas the sensitive organisms blend into the background and we don't recognise transmission events due to these. This was a report by Jim O'Neill, who's an economist, a very good report on tackling drug-resistant infections globally. And this actually was part of this set up a lot of the response to AMR across the world. And if we don't tackle this, the prediction is by 2050, and in fact the data suggests even sooner than then, we will have run out of antibiotics, certainly against gram-negatives. The cost to society will be more than $500 trillion, which is about $12,000 to $13,000 per head of population. And there will be, year on year, 10 million extra deaths due to antimicrobial resistance. And it's a very good report, but one area where it wasn't quite right on is the second recommendation, that some in the developing world will need to focus on proving the basics first by expanding access to clean water and sanitation. What is happening is, in the most sophisticated healthcare facilities in the world, patients are receiving, in essence, fecally contaminated water because they're getting organisms that are being transmitted in water from the wastewater systems to these patients, causing infections. So in the UK, if you look at Manchester, this has been a source for more than 10 years of CPEs into the environment. And this is where, as we talked about right at the beginning, the recognition of the risk from drains. But I suppose one of the questions we could say is, although we recognise the CPEs, prior to that, other organisms would have been dispersed from these wastewater systems because we don't think anything's changed, but our surveillance does not pick this up. And what is the effect of antimicrobial resistance? Well, it's already having an effect. This is a study from America, a multi-center study, and this is looking at patients with bloodstream infections and whether they are on effective empirical therapy or not. And what it found was that roughly 1 in 5 patients with bloodstream infection in the US received discordant empirical therapy, which means that if you looked at the laboratory result, it wasn't active against the organism. Receiving ineffective empirical therapy was associated with increased odds of mortality, even in patients without sepsis. So we're not measuring this, but the gap between effective empirical therapy and ineffective therapy, as antimicrobial resistance spreads, this is going to get bigger, but this is already causing damage in healthcare facilities throughout the world. And they say that early identification of bloodstream pathogens and resistance is likely to produce a population level improvement in outcomes. And this is not surprising, because at the moment, most people's blood culture pathways, the avoidable delays are not measured in minutes or hours, they're measured in days. And if we improve this, not only will we improve the outcomes from patients, we will also help preserve antibiotics for the future and get patients out of hospital quicker. And this is other papers which again verify this, the same what they say. If you're on ineffective empirical therapy, your outcomes are much poorer. So, next time you go to the toilet, you need to consider, are you letting go of a boomerang? And while this may appear humorous, and there is truth to this, we have to recognise that patients are dying from contaminated water and wastewater systems. And just to leave you with this was a paper looking at the water management for construction. So this looked at new buildings from about 1975 to 2017, where there was transmission of infection to patients in newly opened facilities. And what this found was that with new water systems, the commissioning process was a problem in the 1970s, and is still a problem today. We haven't moved on. And what they're saying is there needs to be a change in culture. And the first thing is the impact of construction activity on waterborne disease is preventable, and it should no longer be considered incidental or accidental. And this changing culture needs to be applied to the wastewater systems in the hospitals, the way we deliver blood culture services and many other things, because this is just a change in mindset. We need to know that most of these things are preventable, and there are simple interventions which can prevent the spread of infection and antimicrobial resistance.